So this is a specific talk, a sub-talk in the area of understanding what's actually in production or what version is in any of our given environments. And this section is really focused on APIs and how to understand what version of an API is out there. And for the, basically in a decentralized world, a world where we've gone to a more service-oriented architectures, microservice-oriented architectures, distributed system, ridiculously scalable systems, we involve a lot more APIs than we used to. And for the purposes of this discussion, I'm actually going to include synchronous APIs and asynchronous APIs. And the question is, how do we track what versions of APIs exist, where we've deployed them, and how do consumers of API consumers actually request or know or make sure they bind to the version that they expected, right? So we're going to talk about asynchronous APIs. These are APIs that you can invoke and actually get a reply immediately. This is typically what people think of as APIs, anything plugged into a standard API gateway or can go through an API proxy server. And so generally the things people most commonly today at the time of this think of are REST services, RPCs, and GraphQL, which is just both of those are on HTTPS potentially. So really should say HTTPS, gRPC, and RPC, but I wanted to mix a whole bunch of terms in here and see if anybody noticed, and now I've ruined the surprise. And so anything that's an imperative, anything that's a synchronous API, there's a couple interesting things about it. They can actually change on the request address. So for REST, it would be a different REST URL, or it could be a query parameter. And they also have payloads. A lot of them have payloads, and so they could change in the payload. Either of those would be versionable or cause a version change if you change the resource or you change the payload. Interesting thing about synchronous APIs is if you send old data to a new API or you send new data to an old API or there's some incompatibility, a high percentage of the time the synchronous API will notify you immediately that there's been some failure there, and that's a plus in a way. You'll know pretty quickly, although if you don't have good automated testing, you can still deploy an old or a new version of the API into an environment that can't consume it, and that would be bad. Now, asynchronous is more problematic. Asynchronous are things that are fire and forget. It's basically, and in this case, I'm going to include messaging and event streaming, and they're two different things, but basically they both pass data or commands to other systems asynchronously. They post that and they walk away and go do something else. And typical examples of this, like I said here at this time, are like Rabbit or ActiveMQ, Kinesis streams, Kafka streams, Azure Event Hub, Azure Service Bus, those kinds of things. And the primary method of communication here is the topic name or queue name, and which is an address, and the payload. I typically think of payload versioning, but actually we do both. We version the topics or queues and we version the payload. So we'll talk about that. And a lot of them don't do any schema validation immediately. They can't, but it turns out Kafka is a good example where with their schema registry and things like Spring Library, they actually do immediate schema validation. And so I actually put that leg up over a lot of the other systems. So the two areas in a visual, because you always got to have a graphic to make the video look cool. We're talking about APIs bound to deployments, and stream processors are also APIs, in a sense, bound on deployments. But for the purposes of this diagram, I was really talking about them as payloads. Messaging is really all about payloads. We send data places, and we don't know where those are going to be received. Whereas when I invoke an API, I invoke it immediately on a deployment. You know what? I don't know why I did this. I was talking about something else with this diagram, but basically, people think of asynchronous and synchronous APIs differently, and so they're drawn differently. How do you like that? So we're going to start with the notion that every API change, no matter how small or inconsequential, is a new version. And the debate is whether we document and capture those versions and how we would do that for the various technologies and various synchronous and asynchronous. So every time we make a change, it's a version change. Whether we acknowledge it or not, I changed a library, I added a field, it's a new version. And so the question is, how do we capture that, right? And this highly interconnected web demands stable API versioning. stable understanding of what APIs are available. And in a truly well-architected system, we would never break anything, and this wouldn't be a big deal. But when we get subtle behavior changes, we want to know what version of that thing's deployed out there. So there are two phases of everything we do, both in code and in APIs, and that's cool because APIs are actually implemented through code or configuration. We have design time considerations, and we have runtime time. Oh man, I still didn't fix that. It should say runtime, but I'm going to say runtime time because it's cool. So we have design time, which is everything prior to electrons being used to process data. And so that would be the design time. Could do package versioning, and it could be that the version of our APIs is bound to the version numbers of our packaging. We might do contract versioning as part of that. So we have an artifact identifier for the deployable, and then we have additional metadata in the package that describes the API versions. And the governance side, a lot of times we'll do schema registration, or we'll do API registration. And that includes the metadata that's required, any resource identifier, nomenclature. Although the resource identifier, if we do it as a resource identifier, it's got to be like a metadata version, right? Because in each environment we're going to deploy this, and there'll be a different resource URL, like the host name or the ports or the topic name or whatever it is. So it's really schema registration typically at design time for governance. At runtime, when we deliver this, right, in the runtime, it's basically API versioning built into the executable at runtime. And on the governance side, I think probably the coolest thing we can do is create interrogation endpoints on everything that's deployable. And they'll either be web interrogation endpoints, but that's not required. In Java, they would be JMX. They could be something else. They could be some agent-based thing. Hey, what version of the APIs actually exist here? And those APIs are either independent or tightly bound to the deployable version number. But again, what we need to do is we need to understand what we're going to do at design time and what we're going to do at runtime time. And we have the governance aspect and sort of the in-flight execution aspect of this, and we need to make decisions around that. And you can pick your own approach, but you should have an approach that people understand. If they don't understand why you're doing this, then we either need to educate them or find new people. No, we need to educate them. So I talked about this before. We want to move from implicit to explicit versioning, and we want to have that information available at design time and runtime. And when it comes to versioning, it's a lot like data versioning, API versioning is. And if you look at Avro versioning, they have some good definitions about this. I have a table at the end that describes this. So we have breaking changes and non-breaking changes. Non-breaking changes are ones that the consumers don't really care about. If I were to continue to add functionality in a way that didn't impact today's consumer, right? They don't make use of that new functionality. That's a minor change. I could even add a new endpoint and nobody's consuming it. It's a minor change because nobody's broken. This is the semantic versioning rules that we use for packaging, and you probably need to look at that too. Go read the semantic versioning rules. Major changes are basically any change that breaks a consumer. If we had a behavior change that was big enough to break the consumers, that's a major version. We may decide to change the resource address that we're at to stop or change the payload version in the request in a way that if anybody were to make a request to that endpoint, they would know that they were broken. Now, a lot of times because we don't want to move in lockstep, an API actually needs to have multiple versions up at once. And so we need a way to standardize to support two major versions of a service being deployed at the same time. And that may be two deployments or it may be one deployment. It's up to you. So in our case, we want to capture major and minor version changes at design time and at runtime. And I'm going to talk about a couple scenarios for design time changes, right? And this works for asynchronous or synchronous. If we're doing a microservice, in some ways we're in the best world, right? If we only have one or two endpoints in a deployable, like a function or a lambda, that's cool because that means the version of the deployable could also be the version of the API. And so we could just use semantic versioning on the packaging for that, and that's pretty slick. And so basically that would be that, right? And I said here there's actually two ways. So one of the other things I needed to point out real quick. So if we have single deployable single service in it, the two go in lockstep. We're really talked about the API change only happening when the API behavior changes or the contract changes. That may not be true. We may actually increase an API's minor version number And again, consumers may not care, may never use the minor version, but for all practical purposes, anytime we change a dependency library or anything in the deployable, in any of the code path used by the API, that's at least a patch level change, a minor level change for that. So if we have multiple endpoints in the same deployable, then versioning becomes a little more complicated, right? What we can do is we can make everybody go up in lockstep. So if one of the APIs has a major version change, everybody picks it up. And I've worked places where we did that. It just turned out to be a lot easier. We went from version 5 to version 6 on everything. And because these 3 endpoints, version 5 and 6 were really the same, we just created aliases and version 5 were still out there. And it just meant that we broke the breaking change rule, but it made our packaging a lot easier. The other way to do that is independently version every one of the APIs in the deployable. I have found that beyond my skill to do reliably, but some teams are really good at that, and that's why other people go to microservices. So I hope that was useful, and leave feedback, and have a great day.